Hello class, today I'm going to show you how you can have a non-proportional loading fatigue analysis. Let's see. Workbench. Basically we are going to have different types of load, and some of them can be a cyclic load. So combination of loads which are going to create us non-proportional loading fatigue analysis. Static structure. For this geometry, I'm going to import a geometry we already prepared, which is going to be this axle. I imported the geometry. Let's open model. Okay, geometry is ready. You can see this is an axle, and I'm going to have two types of load, momentum over here and cycling load exactly here, two bearing support here and here, and finally a fixed support there. Let's take care of mesh. Let's see. Let's first check what type of mesh is going to generate for us. Okay, we don't like it. Let me check what type of mesh I'm looking for. Let's change mesh method. Select the whole geometry, apply it, and instead of selecting automatic, which as you saw it generated some triangular mesh, I'm going to get and select hex dominant. So they are going to be quadrilateral mesh, which is going to be much better. Let's see. See, it is going to take some time to generate that mesh, but you could apply some other change. For example, here it's coarse. I'm going to select medium. Right click over mesh. Instead of generating or updating, I'm going to go preview and ask ANSYS to just generate mesh for the surface, to have a preview what type of mesh I'm going to get. So it is going to be much faster, and you can check. Now I can see, okay, this mesh is going to be much better, so let's generate this mesh. So I'm not going by default generating the mesh. No, I'm doing it just for the surface to have a preview, and then if it's acceptable, yes, it's worth it, I can wait for ANSYS to generate that mesh. Okay, mesh generation is enough. It's quadrilateral, and later this week you are going to see why quadrilateral is much better than triangular ones. Okay, Now let's add supports. We said we are going to have fixed support here, two bearing supports for cylindrical support there, another cylindrical support here. Let's go and check the cylindrical support options we have. Radial fixed, so it's not going to radially move. Axial fixed, it's not going to slide here at this x direction, which we like. Tangentially, it's fixed. I don't want to be fixed. I want to be able to, that axle to rotate. So free for tangential, both of them, so our axle can rotate. Let's add moment. So I'm going to add moment there, and magnitude is going to be so let's change to Newton meter. I want to have 500 Newton meter. So let's check. Okay, now we can see our moment is here. Now I'm going to apply the force again here at the larger section, remote force. I want to be at exactly at the center, so this number is a very small number. ANSYS try to create 0, so I'm helping it because it's a 2 times 10 power minus 18, so it's 0. The same thing here, 0, so it's going to be exactly at the center. And the force I want to be component because I would like to know what is the direction, and negative 1250 Newton. So as you can see, it is going to be downward exactly at the center of this circle. Okay, so we applied 2 loads. Let's check everything. One moment about x-axis. Unfortunately, I can't see. Okay. So it is counterclockwise. If you check the right-hand rule about x-axis, you can see it is counterclockwise like this, which is good. And then we have remote force downward 1250 Newton and 2 cylindrical support and 1 fixed support there. Okay, let me add a few usual solutions and solve this case. Again, if your ANSYS had a problem about the mesh size, just go for the coarser mesh. Okay, we have it's not error. Okay, let's leave it. So we have higher stress at these 2 bearing area, and the maximum stress is about this position. If we want to have more details, we need to increase the mesh size, but we may not want to do that. Okay, so let's place the maximum. It's going to be there, and minimum we don't care that much. Okay. I can show you this way. For example, say above show me just the area above 1.5 times 10 power 8. So these areas we have high stress, which is above 1.5 or 150 megapascal. Let me change this to megapascal. Done. Okay, this is a nice idea to know where are the exact maximum stress area. You can neglect the other area, investigate this part, and then whenever you want, include that part. Okay. We did this part. Let's close it. Now, I want to create another static structural, but this time instead of downward remote force, this time I want to be upward. And I'm going to ask ANSYS to combine those two upward and downward forces, which both of them have that moment, 500 meganewton moment with each other, and solve and find the fatigue because of that. To do that, I'm going to right click over solution and click duplicate. ANSYS is going to automatically connect geometry, material to the previous one. Let's see, and model, and we can change everything here. So let's open it. So those two copies are connected to each other. Let's see. I'm going to remote force, and this time instead of negative, it is going to be positive. Let's solve it. So as you can see, I have static structural A5, and the new one is static structure B5. Be careful to solve this one too. So, oh, I made a mistake, sorry. Let me close. I changed this one. So this one is going to be -1, and this one is going to be +1. Okay, I made a mistake. I changed the first one, which wasn't my intention. Let's solve this one too. So both sides are solved. Now let's, where is it? Right click over model, insert, and down the last item is solution combination. So basically I want to combine those two static structural solutions to create that loading and find a solution for these combinations. So click there, nothing here, so you need to right click and add the first one, and then add the second one. Okay, now we need to add the fatigue tool here. So fatigue tool for solution combination. Similar to the previous video, now you need to change everything and make sure the fatigue options are proper for these two selections. So this is not going to be fully reversed because I have some load and some moments. So it is going to be non-proportional. As you can see here, the frequency is similar but different values of forces, and they are changing by time, but it's like a rotating bending. Same frequency, but we can have different loads. Okay, let's see. Stress life, yes, we are selecting this one. Theory, let's use Goodman's theory. Stress, we're happy with that. Yeah, we're happy. Now let's add some solutions, life and safety. Now it's time to solve it. Now you can see we have infinite life for this one. Let's check safety. Safety is 1.3, and yeah. So for this case, we had combination of two loads, and they were non-proportional. And the way we did it, the only way we can do it, is using this duplicating static structural here and changing the load, and then asking ANSYS to combine those two solutions to be able to have this case. This case can happen for many situations, for civil and mechanical engineers. For example, if you have this one is like a shaft with bending and load and vertical load, it could be a column with bending and vertical load, which can cycle through time. Okay, I think this is enough. See you next time.